Good day, everyone. So, today we will tackle the production of more mathematicians in the different European countries and their improvement on early works. The invention of the calculus was one of the great intellectual achievements of the 1600s by one of those curious coincidences of mathematical history. Not one, but two men devised the idea and almost simultaneously. The methods of the calculus of Newton's in England and Leibniz on the continent were so similar that the questions whether Leibniz borrowed the crucial concept from Newton's or discovered them independently give rise to a long and bitter controversy. So, let's start to clarify the story of two men and other mathematicians in the different European countries. Gottfried Wilhelm Leibniz, born in July 1, 1645, and died on November 14, 1716. Gottfried Wilhelm Leibniz is an academic family. From the age of 6, Leibniz was given free access to his father's library. At the age of 7, he entered school in Leipzig. In school, he studied Latin. Leibniz had taught himself Latin and Greek by the age of 12. He also studied Aristotle's logic at school. In 1661, Leibniz entered the University of Leipzig. He studied philosophy and mathematics. In 1663, he received a Bachelor of Law degree for a thesis, Principles of the Individual. Leibzig's idea was to create some universal logic calculus. After receiving his degree, Leibniz commenced a legal career. From 1872 to 1676, Leibniz developed his ideas related to calculus and obtained the fundamental theorem. He also used term-by-term integration to discover series representation of pi. The Calculus of Leibniz. The first published paper on calculus was by Gottfried Wilhelm Leibniz on 1684. Leibniz discovered calculus independently. He had better notations than Newton's. That was called Nova Methodus on 1864. Sir Isaac Newton, born on January 4, 1643, and died on March 31, 1727. Newton's father was a wealthy but completely illiterate man who even could not sign his own name. Young Newton was abandoned by his mother at the age of 3 and was left in the care of his grandmother. Newton entered Trinity College or Cambridge in 1661 to pursue a law degree. Despite the fact that his mother was a wealthy lady, he entered as a Caesar. He studied philosophy of Aristotle. Newton was impressed by works of Descartes. In his notes, certain philosophical questions, Newton recorded his thoughts related to mechanics, optics, and physiological of vision. The years 1664 and 1666 were the most important in Newton's mathematical development. By 1664, he became familiar with mathematical works of Descartes, Viety, and Wallis and began his own investigations. He received his bachelor's degree in 1665. When the university was closed in the summer of 1665 because of the plague in England, Newton had to return to Lincolnshire. At that time, Newton completely devoted himself to mathematics. Newton's fundamental works on calculus, a treatise of the methods of series and fractions, on 1671, or De Methodis, and on analysis by equations unlimited in the number of terras on 1669, were rejected for publication. Nevertheless, some people recognized his genius. Isaac Barrow resigned the Lucasian chair in Cambridge in 1669 and recommended that Newton be appointed in his place. Newton's first work as Lucasian professor was on optics. In particular, using a glass prism, Newton discovered the spectrum of light. In 1665, Newton discovered inverse square law of gravitation. In 1687, Mathematical Principles of Natural Philosophy. In this work, Newton developed mathematical foundation of the theory of gravitation. This book was published by Royal Society with a strong support from Edmund Halley. In 1693, Newton had a nervous breakdown. In 1696, he left Cambridge and accepted a government position in London, where he became Master of the Mint in 1699. In 1703, he was elected President of the Royal Society and was re-elected each year until his death. Newton was knighted in 1705 by Queen Anne. Newton's calculus of series, most important discoveries in 1665 to 1666. Before he studied the works of Descartes, Viety, and Wallis, contributions to differential calculus. Most significant contributions are related to the theory of infinite series. Newton used term-by-term integration and differentiation to find power series representation of many of classical functions. Moreover, Newton developed a method inverting infinite power series to find inverses of functions. Unfortunately, Newton's works were rejected for publication by Royal Society and Cambridge University Press. Archimedes was born and worked in Syracuse, Greek city in Sicily, 287 before Christ existed, and died in 212 before Christ existed. Friend of King Hiron II, Eureka, discovery of hydrostatic law, invented many mechanisms, some of which were used for the defense of Syracuse. Used the method of extrusions to show that the volume of sphere is 2 over 3 that of the enveloping cylinder. Other achievements in mechanics usually attributed to Archimedes: the law of the lever, center of mass, equilibrium, hydrostatic pressure. According to a legend, his last words were "Stay away from my diagram," addressed to a soldier who was about to kill him. Minima, maxima, and tangents. The idea of differentiation appeared later than that one of the integration. First result construction of tangent line to spiral by Archimedes. No other results until works of Fermat on 1629. John Wallis, born on November 23, 1616, from Ashford, Kent, England, died on October 28, 1703, from Oxford, England. Wallis' academic talent was recognized very early. 14 years old, he was sent to Felsted, Essex, to attend the school. Wallis learned rules of arithmetic from his brother. In 1632, he entered Emmanuel College in Cambridge. Bachelor of Arts degree. Topics studied included ethics, metaphysics, geography, astronomy, medicine, and anatomy. Wallis received his master's degree in 1640. Between 1642 and 1644, he was chaplain at Hingham Essex and in London. Wallis became a Fellow of Queen's College, Cambridge. He relinquished the fellowship when he married in 1645. Wallis was interested in cryptography. Civil war between the Royalists and Parliamentarians began in 1642. Wallis used his skills in cryptography in decoding Royalist messages for the Parliamentarians. Since the appointment to the Savilian Chair in Geometry of Oxford in 1649 by Cromwell, Wallis actively worked in mathematics. The Arithmetica Infinitorum of Wallis in 1655, an attempt to arithmetize the theory of areas and volumes.